Now we will solve the two sum problem using two pointer method. In the previous two videos we have solved the same question using brute force method and in the just previous one video we have solved this same question using hash map. So brute force was taking the time complexity of big O of n square and hash map was taking the time complexity of big O of n but space complexity of big O of n. But what if we want to solve the same question? But what we want to solve the question without taking this space complexity? So two sum is the two pointer is the solution of this question without using any extra space. So suppose there is an array. What was the previous array? 2 6 5 8 11, 2 6 5 8 11. So this was our array and target was 14. So in the two pointer approach there are few steps of doing this. So step number one, we will sort the array and then the second step is take two pointers left at 0 and right at n minus 1. Basically we are taking one pointer here and one pointer here and the step 3 is we will sum those two values of those two pointer. There will be a sum. If sum is less than the target value, then we will increase the smaller pointer, the pointer which is pointing to the smaller values, that is the left one. If sum is greater than the target, it means we need to decrease this pointer which points to the greater elements because sum exceeds the target. That's why we need to decrease that pointer which points to the greater values. That means we need to decrease right minus minus. So these are three steps by which we can do solve two sum problem using two pointers. So now move forward. Suppose no, what was the array? 2 6 5 8 11. First step, in the first step we will sort it 2 5 6 8 and 11. Now take two pointers. One L here and one R here. This is the left pointer, this is R pointer. Let's run a loop L less than R. This we will take a loop and we will check 2 plus 11 is equal to 13, which is less than our target value. Our target value is 14, so it is less than our target value. So we need to increase this L from here to here. So now 5 plus 11 is equal to 16. It exceeds the target. It means if it exceeds the target, it means we need to decrease the bigger value. So bigger value points by R pointer. So we will decrease now R here. Now R1. Now we will decrease R from here to here. So 5 plus 8 is equal to 13. So this is less than target. It means we need to increase our smaller value. So we will increase our L from 5 to 6. So now 6 plus 8 is equal to 14, which is equal to target, and we get our target by using two values, sum of two values. So we will return to the main function that we got our two values which sums to 14. So these are the two values. So I think you got the main idea behind using two pointers. So let's write a code of this thing. You can see again. So let's write the code part. Pseudo code. So this will be the pseudocode. So don't say in the comment that your code is not right or wrong, code is wrong. So first of all, we will take a pointer left is equal to 0 and right is equal to n minus 1. We will run a loop from, no, let's take a while loop, while L left less than right. So these two pointers L are left and right, and we have to increase this or decrease this, and as soon as they crossed each other, it means there are no any elements which sums to 2. So if these two pointers crosses each other, it means no element present which sums to 14. So let's move further. So now we will take some. Now we will do sum of these two elements, ARR left plus ARR right. If our sum is less than target, as you know what we need to do now. If sum is less than target, it means we need to increase our smaller pointer, which is left plus plus. Else, if sum is greater than target, it means we need to decrease the bigger pointer. The pointer we need to decrease the pointer which is pointing to the bigger elements if sum is greater than target. So now this else if sum is equal to target, it means we got our two values which sums to 14, and we will return from here. So we will return from here, and whatever being asked in the question we will return from this. So this is the code part. Now discuss about the time complexity. So as we can see, we are iterating only once in the entire array. Either we will increase the left or decrease the right. So this will be our window, or sometimes this will be our window. So basically we are iterating for the n time, for one time. So time complexity will be big O of n, but we need to take care because we have also sorted the we have also sorted the array in the first step. So for sorting, the time complexity will be big of n log n. So this is for iterating and this is for sorting. So our time complexity will be n plus n log n. And space complexity, as we can see that we are not using any extra space in our code, so that's why our time complexity sorry space complexity will be big O of 1. And in the previous video, uh, we were solving this question using HashMap. There will be space complexity of big O of n. So now we have reduced this space complexity from big O of n to big O of 1. But in the that we will be the time complexity was big O of n. Now the time complexity has increased. So it depends on you which solution do you want to use, this or this one. This was the hash map and this is from two pointer. If you want to solve this question using without any extra space, so go for this part. And if you want, if you have no problem for you by using any extra space, so you can go with this solution. So time complexity is big of n plus big of n log n, and space complexity is big of 1. So for this question two pointer approach, these are the complexity part. Okay, thank you.